Hello, welcome to AWS Architect Associate. So in today's session, we'll be going through this Module 9 Challenge Lab, creating a scalable and highly available environment for the cafe. So let's understand the scenario. So the cafe will soon be featured in a famous TV food show. When it airs, Sophia and Nikhil anticipate that the cafe web server will be experiencing a temporary spike in the number of users, perhaps even up to tens and thousands of users. So currently the cafe web server is deployed in one availability zone, and they are worried that it won't be able to handle the expected increase in traffic. So they want to ensure that their customers have great experience when they visit the website and they don't experience an issue such as lags or delays in placing order. Okay, so we have understood the scenario. So let's learn the lab overview and the objective. So in this lab, we will use elastic load balancing and Amazon EC2 auto scaling group to create a scalable and highly available environment on AWS. So after completing this lab, we should be able to inspect a VPC, update a network to work across multiple availability zones, create an application load balancer, create a launch template, create a auto scaling group, and test load balancing and automatic scaling. Okay, so when we start this lab, so this is how the architecture would look like. So you can see, so we'll have multiple availability zone, and so we'll be having public subnet 1 and 2 in different availability zone, and we'll be having private subnet 1, 2, 3 and 4, and we are having primary DB instance in our private subnet, and we are having our cafe application server inside this private subnet, and we have created an AMI of this EC2 instance, and also we have an internet gateway here which is connected to the public subnets and a net gateway here. So at the end of this lab, we'll be seeing that we have this application load balancer, and we are having this auto scaling group, and this auto scaling group will be creating a new instances based on the load. And also we have created a new gateway, net gateway here. Okay, so let's start this lab, and let's start with first challenge. So a business request for the cafe implementing a scalable, highly available environment. So in task 1, what we have to do is we have to inspect our environment. So let's start the AWS. So in this task, we will evaluate the current state of our lab environment. So we need to explore the lab environment, including how the network is set up. So we may want to start with the Amazon VPC console, and once we explore the lab environments, we can go and answer these few questions. So let's open this, access the multiple choice question. So with this, let's start with VPC. So by default, we should have lab VPC created for us. Let's go to VPCs. So we have this lab VPC created for us. So if we go and check this VPC, let's select the VPC, lab VPC, and let's go through different subnets. So we have multiple subnets. So we have private subnet 1, 2, 3 and 4, and we have public subnet 1 and 2. That means we have in across different availability zones. So we can check from here. So yes, so we have across different availability zones. Okay, so we have multiple route tables here, and then also we have internet gateway set up for us, and we should also have net gateway and so on. Okay, so let's start with the question number 1. So which ports are open in the Cafe SD security group? So let's go to security group. So I think we should go from the EC2. Let's go to EC2. So the security group here mentioned is for the VPC only. Let's go to the instances. Let's choose this. Let's go to security. So we have this security group here, Cafe SG. Let's open this, and you can see the inbound rule, and it is open for port number 80. Okay, so it should be port number 80. And let's continue with question number 2. So can you connect from the internet to the instance in the public subnet 1? So like, since we have this internet gateway attached to the VPC, so we have attached this to the VPC, and let's go to one of the public subnet 1. So let's go to subnets, let's go to public subnet 1, and then from here we can check the route table. So since we have this internet gateway access here, so we are able to connect to the internet from the public subnet 1. Should an instance in private subnet 1? So yes, they should be able to, because we have the net gateway installed. Let's choose private subnet 1, and let's go to route table. So since we are routed this destination to the net gateway, we should be able to connect to the internet from the private subnet 1. Should an instance in private subnet 2 be able to reach the internet? So let's go to private subnet 2, and let's go to route table. So since we don't have any net gateway, since we don't have any routing to the net gateway, so we should not be able to connect to the internet. Let's say no. Can you connect to Café web server instance from the internet? So since the instance has a public IPv4 address, so we should be able to connect. But to confirm that, we can go to the route table. But since we don't have any port number 22 open for that, so we should not be able to connect from the internet. So what is the name of the Amazon machine image AMI? So for that, let's go to EC2, and then we should have here AMIs, and then we have this Café web server image. Café web server image. So let's submit. Let's submit. Let's submit. Let's submit. Two more. Let's submit. Let's submit. So we have completed these questions, so I think I can close this tab, and let's move ahead. So in task 2, we need to create a net gateway for the second availability zone. To achieve a high available, an architecture must span at least 2 availability zones. However, before you launch Amazon Elastic Compute instance into your web application servers in the second availability zone, you must create a net gateway for them. So a net gateway will allow instances that do not have public IP address to access the internet. So let's create a net gateway in the public subnet in the second availability zone. So to do that, let's go here. Let's go to net gateway. So you can see here, this net gateway is created here. We need to create a net gateway, another net gateway. Let's create a net gateway. So let's say learn with Pratap net. So let's choose in the public subnet in the second availability zone. It should be inside the public subnet. So let's say public subnet 2 should be public. Let's allocate an IP address. Let's create a net gateway. So we have added this to a public subnet 2, and the old one should be in the public subnet 1. Okay, so we've successfully created a net gateway, and so now we need to configure the network to send inbound traffic from instances in private subnet 2 to the net gateway you just created. Okay, so let's go to subnets. So before that, I think we can go ahead and check private subnet 1, and we can check the route table. So we are routing this 000 to the net gateway. Okay, so we need to do the same. Let's go to private subnet 2. Let's go to route table, and let's go to private route table 2. So this is the route table, and let's update the inbound rule. Edit routes, add route, go to this 00, and it should be to net gateway, and learn with Pratap net, and let's save changes. So let's go to the subnet, and now let's check the private subnet 2. Let's check the route table. So now we have this, we have routed this all the traffic toward the net gateway, right? Okay, so let's continue with task 3. So now we need to create a bastion host named instance in the public subnet. So it should be in the public subnet. So let's create a bastion host. Let's follow the same criteria here. Let's go to EC2. Let's go to instances. Let's launch an instance. So it should be bastion host. So let me pull this closer. And the Amazon machine image should be Amazon Linux 23 AMI. So this sounds good. This sounds good. Instance type should be T2 micro and uses the Voki key pair. So let's say Voki key pair, and let's edit the network configuration. And as it says, we should create in one of the public subnet. So let's create in the public subnet. Let's choose lab VPC and let's choose public subnet. So let's choose public subnet 2 and let's auto assign the IP, and only allows the following traffic. So we need to create a new security group. So let's say here bastion host SG and port SSA. So it should be type SSH port 22 and source should be our IP address. So this sounds good, and my IP. Okay, I think the other part is done, and let's create an instance. So we have launched a new instance called bastion host. So now let's create a launch template. So during the lab setup, Amazon AMI was created from the Café web server. So let's create a launch template by using the AMI that was created during the lab setup. It must meet the following criteria. So in order to create a launch template, we should go here. We should go in the launch template. So since there is no launch template, let's create a new launch template. So do we have any name? So we don't have any name. So let's give this name. Let's say learn with Pratap launch template. Okay. Launch Pratap, and let's follow along. So we need to choose an AMI. Let's say my AMI owned by me, and we should select the Café web server image. So the instance type should be T2 micro, and we need to use as a new key pair. So since I think we need to create a new key pair, create new key pair, Voki2 PAM. Let's create a key pair, and documents and AWS. Let's save, and then key pair security group should be Café SG. So I'm not sure why I don't see the Café SG here. So it's here, Café SG. Okay, and then okay, so I think we have chosen instance type, key pair, security group, resource tag. So let's go to resource tags. And let's create a new tag. Key should be name, and this will be web server. Web server will be instance, should be instances. Okay, so in the IAM instance profile, we need to choose Café role. Let's go to advanced detail. So we need to choose Café role, and with that I think we can create the launch template. So a launch template is successfully created. So let's continue with task 5, creating an auto scaling group. We need to create an auto scaling group. So for that I think it should be this side, auto scaling group. Let's create an auto scaling group, and then do we have any name here? So we don't have any name. Let's say learn with Pratap auto scaling group. So let's choose a launch template. This sounds good. Let's go to next. use the VPC that was configured for this lab. So it should be lab VPC, and uses the and subnet, use private subnet 1 and private subnet 2. Private subnet to 1 and private subnet 2. So it should be private subnet 2. Okay, subnet 1 and private subnet 2. Skip all the advanced option. Let's go to next. Has a group size configured as desired. Let's go to next. So desired capacity 2, minimum capacity 2, and maximum capacity is 6. So 2, 2 and 6, and enables the target tracking scaling policy. So let that be the name. So the metric type should be average CPU utilization. That sounds good. Target value 25, and instances need will be 60. So let's go to next, and let's go to next, and let's go to next, and let's create an auto scaling group. So once this auto scaling group is created, we should go to EC2 and let's go to instances, and now there should be, after a few minutes, so the auto scaling group should create a couple of instances. So you can see we have this web server couple of instances that is initializing now. So this is because in the auto scaling group we have said that we want a desired capacity of 2 instances. Okay, so now let's create a load balancer. So now that the web application server instances are deployed in private subnet, you need a way from the outside world to connect to them. So in this task, you will create a load balancer to distribute traffic across the private instances. So let's create an HTTP application load balancer that meets the following criteria. So in order to create a load balancer, we have to go to load balancer. Let's create a load balancer, and we want HTTP application load balancer. Let's create, and let's see if we have to give name here. I don't think there's any name. So let's say learn with Pratap LLB load balancer. It will be internet facing, and we need to choose lab VPC here. So let's choose the 2 public subnet. Public subnet 1, this sounds good. Public subnet 2, okay. And then skip the HTTPS security configuration setting. So where is that? Okay, so now we also need a security group. Create a new security group that allows HTTP traffic from anywhere. So we need to create a security group. Seems like we cannot create from here, so let's create a security group. Learn with Pratap LB load balancer SG. So let's add this. So it should be in the lab VPC, and let's add an inbound rule. It should be HTTP, and it should be from anywhere, and let's create a security group. So now let's refresh, and you can choose the learn with Pratap load balancer security group. Okay, and let's remove this default, and then target group, we need to create a new target group. Let's go and create a new target group. It should be instances. Target group name will be learn with Pratap target group. And skip registering target. So before lab VPC, HTTP1, and I think all these things look good. Let's go to next. So it says that we can skip the registering target. create target group. So we've created the target group. So let's go to load balancer, let's refresh here. So we should have this target group, and I think we can skip every other things. Okay, so let's create a load balancer. So we need to wait for this load balancer to be active. So it's currently provisioning, so let's wait until this is available or active. So after this, we need to do, what we have to do is we have to modify the auto scaling group. So we need to add the target group we created in the load balancer configuration. So let's go to auto scaling group and let's modify this auto scaling group. Let's go here, let's go to action, let's say edit. Launch template is good, it's good, network is good. So here we can say application, yeah, okay. So I think we have modified the auto scaling group. Let's update. So let's go to load balancer and copy the public DNS. So this is the DNS. Let's go here and let's say Café. So yeah, finally we're able to access our Café using the load balancer. So the Café load balancer should load. If it does not, go back through the lab task and check your work. So we should always keep an eye in this network configuration, our route tables, load template, okay. And then in task 8 we need to, like, I think all this we are able to test successfully. So in task 8, testing automatic scaling under load. So in this task you will test whether the Café application scales out automatically. So by using SSH pass through to the bastion host instance, use SSH to connect to one of the running web server instance, okay. So I think this part we can test it, but it's okay. Let's skip for now. And with this, let's submit our task. So since we've completed our lab, so I'm submitting our lab. Let's check the grades. So we have not scored anything yet. So yes, you can see we got scored 36 out of 36 for this lab. So I think you are also able to follow along with me, and hope to see you in another module.